Problem 6. Let fx be 5 sine inverse of x cubed. Find its derivative. Okay. So, fx is 5 sine inverse of x cubed, right? To find its derivative, we need to use the chain rule. First, recall, derivative of sine inverse x is 1 by square root 1 minus x squared. So I'm going to put that argument x cube and call it u. So du dx is 3x squared. So derivative with respect to x of 5 sine inverse x cubed is derivative with respect to u of 5 sine inverse u times du dx. So this gives me 5 over square root 1 minus u squared times du dx is 3x squared. So in all, that gets me 15x squared over square root 1 minus u squared. U was x cubed, so its square is x to the power 6. So let's write down that answer. 15x squared over square root 1 minus x to the power 6. Okay, I hope you can see. There you go. Next. Find the derivative of, right? Y equals tan inverse of square root 6x squared minus 1. Y fx is tan inverse of square root 6x squared minus 1. Again, we are going to use chain rule. Recall, derivative of tan inverse is 1 over 1 plus x squared. So, I'm going to call this input argument u. U is square root of 6x squared minus 1. So, du dx is, this itself calls for chain rule if you recall, but this you know how to do. So, 1 by 2 square root of 6x squared minus 1 times derivative of the object inside 12x. So that's du dx. So d by dx, so derivative of my function fx is d by du of tan inverse u times du dx. Well, tan inverse, we know 1 over 1 plus x squared. So in this case, 1 over 1 plus u squared times du dx, we just calculated. Okay, so 12x over 2 square root 6x squared minus 1. U itself is square root 6x squared minus 1. So u squared will be square of that quantity. So notice I get 1 over 1 plus 6x squared minus 1. You see the square root square. And here I have the rest. Okay. So these two simplify 6x squared. Those two reduce 6x. 6 reduces the 6. X reduces the x squared. I'm left with 1 over x square root of 6x squared minus 1. Let's write that down. Okay. 1 over x square root of 6x squared minus 1. All right. Fantastic. Next, let fx equals 5x sine inverse x. Find the derivative and evaluate the derivative at 0.4. So this calls for product rule. Derivative of the first, second as it is, plus first as it is, derivative of the second. Okay. So that gives me 5 sine inverse x plus 5x over square root 1 minus x squared. Or what do I do to evaluate at 0.4? I simply substitute. That's it. So let me write down this expression for the derivative and then evaluate it. So 5 arc sine of x plus 5x divided by square root 1 minus x squared. Here, what I'll do is I'll simply copy paste. and replace each x by 0.4. That's all I need. Don't forget to put parentheses. Then you're multiplying and taking square roots, squares, and so on and so forth. That's it. Check. Very good. Next. Derivative of arc cosine of e to the power 2x. Again, we need chain rule. Arc cosine is cosine inverse. Recall derivative of cosine inverse is negative 1 by square root 1 minus x squared. So I'm going to replace e to the 2x by u. Then derivative du dx is 2e to the 2x. This is straightforward. So derivative with respect to x of cosine inverse e to the 2x is derivative with respect to u cosine inverse u times du dx. Derivative of cosine inverse u is negative 1 by square root 1 minus u squared. Du dx is 2e to the 2x. So eventually I have a negative 2e to the 2x over square root 1 minus e to the 4x. Let's not forget u is e to the 2x. So squaring it gives me e to the 4x. So let's go. Negative 2 e to the power 2x over square root 1 minus e to the power 4x. Okay. Next. 8 arctan 6x. Find its derivative and evaluate it at 3. Okay. This is problem 10. So 8 arctan 6x. Arctan is nothing but tan inverse. Find the derivative. You want to evaluate it at 3. Okay. We are going to use chain rule here. Tan inverse, its derivative is 1 by 1 plus x squared. So all I need to do is substitute. Use u equals 6x. Then du dx is 6. So derivative is d by dx of 8 tan inverse 6x. This is with respect to u first and now multiply by du dx. So that fetches me 8, 1 by 1 plus u squared. Du dx gets me a 6. So in all that's 48. 1 plus 6x squared, 36x squared. All right. So derivative with respect to x is 48 over 1 plus 36x squared. Okay, I hope it's clear. U is 6x, so it's squared. Now, I want to evaluate it at 3. When x is 3, that becomes a 9. So that's all the difference. I don't even need to calculate. I'll copy and I'll paste that x squared becomes 9 because x is 3. Wonderful. A last question. 5 arctan 4e to the x. Find its derivative. Oh, this is not the last question. I'm sorry. So 11th question. 5 arctan 4e to the x. So arctan is tan inverse. Use chain rule. Substitute u equals e to the x. So derivative with respect to x is derivative with respect to u times du dx. So 5 tan e to the u inverse u. Its derivative is 5, 1 by 1 plus u squared. And derivative of 4e to the x is 4e to the x again. So u is 4e to the x, so I'm going to square it. So notice that fetches me 20e raised to x upstairs. And downstairs I have 1 plus 16e raised to 2x. So that's the 11th question. 20e raised to x over 1 plus 16e raised to 2x. Check. Fantastic. Next, integral. Well, this is straightforward. That's the formula. Integral of 1 by 1 plus x squared is tan inverse x. So this is arc tan of x. That's your simple formula. Integral from 0 to 0.7 dx by square root 1 minus x squared. This is nothing but arc sine or sine inverse. Now all I need to do is apply the limits. 0.7 first and then 0 second. Now notice sine inverse of 0 is 0, so that doesn't get me anything. All I need is sine inverse of 0.7. Sine inverse is nothing but arc sine of 0.7. Next, this is the last problem. Integral 1 to square root 5, 2 over 1 plus x squared. Now that is a tan inverse. So 2 is 2. 1 over 1 plus x squared, integral is tan inverse. And the limits are square root 5 and 1. So I have a 2 outside. Arc tan of square root 5 minus arc tan of 1. So let's write that down. 2 times arc tan of square root 5 minus arc tan of 1. Close parenthesis and check. That completes our problem list for section 6.6. So before I forget, all of this, my lecture closely follows text by James Stewart, okay, which is the textbook for our class. All right, so next topic will be covered in our next videos. Until then, bye.